Hey there, Kyle. All right, so we're going to take a look at each one of these sections. I'm going to try to do an example problem from each set and then hopefully give you what you need to be able to be successful on the rest. So when we're looking at these, this is really about evaluating using the unit circle. So what I'm going to do is I'm going to look at this guy here, the secant of 17 pi over 3. So I'm going over here, this is number 7, and it's a secant of 17 pi over 3. So what you essentially want to do when you're evaluating something like this is first you want to figure out what is this angle representing. So I'm going to actually look at this in terms of how many circles exist. So 3 goes into 17 how many times? 4 would be 12, 5 would be 15. So we're looking at 5 with 2/3 left over, right? So I'm looking at 1, 2, 3, 4, and then 5. And then we're looking at 2/3 of a semicircle left over. So that's putting me into quadrant 4. And what I know about secant is the reciprocal of cosine. So that means I'm really going to be evaluating the cosine of whatever this reference angle is. And because this is division by 3, this is going to have a reference angle of 60 degrees. I hope you recall that. So division by 3, the reference angle is 60 degrees. So if I evaluate the cosine at 60 degrees, the cosine of 60 degrees is equal to a half. This is in quadrant 4, and I know that cosine is positive in quadrant 4, so I'm good to go on that, but recall this is the reciprocal function. So I would like to take the reciprocal of the value that I get. So in this case, the secant of 17 pi over 3 should be the reciprocal of a half, or the number 2. So in these problems, what you're doing is you are figuring out the location on the unit circle, then evaluating the reference angle, deciding if it's positive or negative, and then if it's a reciprocal function, actually taking the reciprocal of the value. The one other thing I wanted to note is maybe something like this. If I asked you to evaluate the cosecant of 3 pi over 2. Okay, so where's that location? So this is 1 1/2 semicircles, right? So we're looking at 1 1/2. When it's on an axis, there is no reference angle, right? These are the ones that I really just want to identify the location. And since cosecant is the reciprocal of sine, and our points are always written as cosine comma sine, I really want to look at the second value. I want to look at the y value. So the cosecant of 3 pi over 2 is going to be the reciprocal of -1. So the reciprocal of -1 is equal to just -1. So that's what you're looking at in that set. If you have any questions on those, definitely shoot me a text. When you're looking at these are just asking you to figure out what is the angle value that would produce these. So for instance, our cosine of -1/2. Okay, so it's asking you, when is cosine equal to a half? And the quadrant would have produced a negative value. So the cosine is equal to a half at 60 degrees. That's my reference angle. So a reference angle of 60 degrees. And then the location of where that would happen is going to be either in quadrant 2 would give me a negative value, or quadrant 4 would give me a negative value. So I'm looking at 120 degrees, or 60 degrees past this, 240 degrees. And if they ask you to figure it out in terms of radians, this would be 2 pi over 3, and this guy would be a little bit past, so I think it's 4 pi over 3. All right, so that's that first set for trig. In this guy, you would want to use a calculator to evaluate it using one of your trig functions. So hopefully you'll remember how to do that. So I'm going to post this, and then I'm going to ask you to take a look at the next video.